Hello, this is the genuinely approachable Sudoku for the 15th of January 2024. It is Cupid Sudoku by Clover. So let's take a look at the rules of this puzzle. Normal Sudoku rules apply, so the digits 1 to 9 appear in every row, every column, and every 3x3 box. The digit in an arrow cell, so these are arrow cells, must appear at least once more in the direction that the arrow is pointing. Not necessarily in the immediately adjacent cell. So, okay, for example, there is a 1 in this cell here. Therefore, in this direction, there must be at least another 1. So there must be a 1 here or a 1 there, basically, what it's saying. So if I had this be like a 2, then there would have to be a 2 in this direction. Okay, so those are the rules. I think I get them. With that, let us begin solving. So the example actually said that if there was a 1 here, then there must be a 1 in this direction. So one of these are 1s, but this is not a 1 because of the 1 in the box. So 1 goes there. This one also means that there's a 1 in one of these directions, which cannot be in this box, so the 1 goes there. And wow, actually that happens 4 times throughout the entire puzzle, so that's where we go with our 1s. The 1s in this box must therefore be here, which gives us all 9 1s. Okay, very round so far. We don't get any other digits on arrows though, so it is time to do the Sudoku. So 6 is in one of those cells. There's actually not a lot, and I think these mean there's 8 is in one of those cells. Oh, okay, never mind. This is actually a bit of reverse logic, I think, because this cell must appear in one of these cells. So rather than one of these being the same as this, we can also think about it as this being the same as one of these. And clearly it cannot be 1 because of the 1 already in the box, and therefore this must be a 6. Another way to think about it is, if this was any other digit, let's say a 7, then this arrow fails because there is no 7 in any of the cells that it sees. So this can't be 7 and must be 6. And I think similarly this cannot be 1 and therefore must be 6. And this propagates throughout the grid. This cannot be 1 and therefore is 8. And this cannot be 1, so is therefore a 9. And this actually appears several more times actually. This cell is one of those cells but cannot actually be a 1. So it cannot follow any of these and therefore must be that cell. So that's 3. This cell, same logic, must be a 5. This cell, same logic, must be a 4. And I believe this cell, yes, same logic, must be a 2. Okay, wow. So that's been really clean so far. The logic is very clean. I like that. Can we do Sudoku now? Yes, 6 in this box goes here. And I would then say, where else can I make that same type of deduction? I want to make this like a rotationally symmetric thing, but I don't think we can do the same for any of the cells outside. Oh, 9 in this box can't be in those cells, so 9 goes there. 5. Oh, I see. 5 in this box. Those 2 5s see everything but this cell, which means that one of these cells must be a 5 because there's a 5 here. So that must go there because this can't be 5. I mean, it isn't 5. Okay, so we are veering off this rotationally symmetric path now. We're just doing random things that we spot. 8 in this box. It must now be there because these can't be 8. And yeah, okay. I see some okay logic, but I don't think we need to use that yet. So what are those digits actually? I think I must just say those are 2, 3, and 7. Okay, fine, I'll do it. Let's look at this box. Where does 6 go? 6 can't go in those cells or that cell by this 6. Oh, actually this 6 sees that cell as well, so 6 just goes there. Okay, no difficult logic required. So 6 sees those cells and that cell, 6 sees that, so this has to be 6. and therefore in this box 6 must go there, which I think gives us all our 6s. 6, yes it does. Okay, very nice. What else can we do? 5s maybe? 5's in one of those cells. Doesn't do much. Again, 5's in one of those cells. Might be time to use to look at these. No, not true, not true. Not true. I think we still have to do more Sudoku. Hold on, give me a sec here. I can just try filling in the digits right now. So these are 2, 5, 8, 2, 4, 5, 8. But these can't be 5 or 8. So that's a 2, 4 pair. This 2 actually sees that cell, so that's 4, that's 2. These are therefore like that. This 8 sees that, so that's 5, that's 8. Okay, so this 2 means one of these cells are a 2. In this row, the digits remaining are 3, 5, 7. Yep, can't find a way to resolve that yet, but this is not a 5. These cells are... Oh, these cells must contain a 3. So yeah, actually they must contain 3 and 7. So those are 3, 4, 7. Which means that this can't be 3 or 7, it must be a 5. Those digits are 4 and 5. And this digit is therefore an 8. This 5 disambiguates this, making this a 4. This must therefore be 5. This 4 means one of these cells are a 5, but that's not... Oh, sorry. One of these cells is a 4, but this is not 4, so 4 goes there. Okay. This is a 2, 3, 7 triple. These are... Well, these are also 2, 3, 7. This can't be a 3. This is... Well, this is also... Wait. This is also 2, 3... No. This 2 sees that. So this is not 2, 3, 7. It is actually... 3, 4, 7? No. 3, 3, 7, 9. Yes, 3, 7, 9. We can't do anything with that though. Sure. Okay, let's look at other spots. Because you have a lot more digits now. Like, I don't know, maybe this 9 and this 3 over here. The 3 in this box must be here because of these. So there's a 3 in one of those cells. Sure. 9 in this box. Yeah, this 9 sees that and this 9 sees that, so 9 goes there. The remaining digits are 2, 4, and 7. This is not 7 or 4 and is therefore a 2. So this 2 sees that, that's no longer 2, making this a 2. That does resolve this. And because this is now a 3, 9 pair, this must now be a 2. That must now be a 7. Now that's a 2, 3 pair, which looks up here, so that is a 7. That is a 3. This cell is just 4. These cells are, I think, 5 and 8, which is resolved by that. So 8 here, 5 there. These are 7 and 9, which is resolved by this. 9 there, 7 there. These cells are 4 and 5, which are resolved. 5 here, 4 there. These are 2. Well, I can see those first. Those are 7 and 8, which have yet to be resolved. This 7 sees that, so that's 4. That's 7. This is 2 or 3. Yeah, okay. Okay, and also look at these. These are 3, 8, 9. But this can't be 8. So 8 in this row has to be here. That makes this a 7. That's 8. This 7 sees up there, so that's 3. That's 7. This 3 sees down here, so that's not 3, making this a 3. Therefore that's 2, that's 3. So now these two cells are... Well, I can just look at that. Those are 2, 4, and 9. This 2, 4 sees that, so that's 9. This 4 sees that, so that's 2, that's 4. This is 2. This is it 9? I think it's 9. That's 3, that's 9, that's 3, and the last digit is a 7. which solves the puzzle. Alright, well that was cool. I hope you enjoyed that. Certainly an interesting rule set. So yeah, I'll see you now. Bye bye.